Alright, so these are the last notes of the unit, and you can pause the video if you need to write those down. But we're going to go ahead and start problem 1. So to write an equation, you're going to take each of the numbers that they give you, and you're going to come up with factors. So -1 corresponds to x plus 1, 2 is x minus 2, and 3 is x minus 3. And I'm going to say y equals because it should be an equation. Alright, so if you notice, they're just the opposite numbers, and it's in a binomial with an x in there. Alright, so now you need to multiply, and I'm just going to take the first two and multiply those. Since they're both binomials, I can FOIL. So x squared minus 2x plus 1x minus 2. And if I combine my like terms, I get x squared minus 1x minus 2. So now I still need to multiply it by the x minus 3, which you could either use box method or distributing. So let's just distribute. X squared times x is x cubed. X squared times negative 3 is negative 3x squared. And then I'm just going to keep going. So negative x times x is negative x squared. Negative x times negative 3 is plus 3x. And then use another color. Negative 2 times x, we got negative 2x, and negative 2 times negative 3 is plus 6. So now that I've done all my multiplying, I just combine my like terms. So x cubed minus 4x squared plus x plus 6, and that's a y equals. So you just basically worked backwards. They gave you the answer, you came up with the equation. So here would be a great way to check to see if you have the right answer. I'm just going to go to y equals, and I'm going to type in the equation that I have. X to the third minus 4x squared plus x plus 6. Okay, and then hit graph, and if I did the correct equation, then I should have x-intercepts at -1, positive 2, and positive 3, which I do. All right, so same thing for problem 2. We're going to say x plus 3, x plus 1, x minus 4. And this time I'm going to say f of x, because that's the same as y equals. All right, so I'm going to multiply x squared plus 1x plus 3x plus 3, and that gives me x squared plus 4x plus 3. So remember, you still need to multiply it by the x minus 4. So this time I'm going to use the box method, because that's what we did earlier in the chapter. And again, you can use whatever method you prefer. All right, so if I multiply everything by x, I get x cubed plus 4x squared plus 3x. And then multiply everything by negative 4, I get negative 4x squared, negative 16x, and negative 12. And when I add my like terms, they should be in all my diagonals here. So I have f of x equals, right, x cubed. These cancel out because that's 0, minus 13x minus 12. So there's my equation. Just like on the last problem, I'm going to double check to see if I have the right answer. So x cubed minus 13x minus 12, and I should have the x-intercepts of negative 3, negative 1, and 4, which I do. So perfect. All right, flip over to the back. This is almost exactly like what we did yesterday, except some of our problems will have x to the 4th in them. All right, so just like we did yesterday, we're going to start with p's over q's. P's are all our factors of the last number, so 1 and 36, 2 and 18, 3 and 12, 4 and 9, and 6 times 6. And all our factors of q are plus or minus 1. So any of these numbers over these numbers, and I'm going to use my calculator to find at least one solution. So I have x cubed minus 4x squared plus 9x minus 36. If I hit graph, I need to find a number where this graph crosses the x-axis, so it looks like my x-intercept is at 4. If you don't remember, or if you can't tell, then you could hit the number 4. So hit trace, then 4, and then hit enter. And you can see 4, 0. So I'm going to do synthetic division, just like we've been doing before. Okay, and if 0 is my remainder, that's a good thing. Okay, so now this is 1x squared plus 9. Right, there's no x's. And I can solve this any way I want. So you can solve with, let's do the square root method. So if I subtract 9, I get x squared equals negative 9. And to undo a square, I take the square root. So I get plus or minus. It would be 3, but since it's negative 9, it's 3i. All right, so my number of solutions I should have is 3, right? I have 3i, negative 3i, and then don't forget that 4 was another solution from earlier. All right, so if you notice, you can't see the whole graph, but there's one real solution and there's two imaginary solutions. So that might be another thing that was different from yesterday. All right, with number 4, you have to first subtract 32. So we have x to the 4th plus 4x squared minus 32 equals 0. All right, so my p's over q's, I'm going to make factors of 32. So we got 1 and 32, 2 and 16, 4 and 8. Factors of the lead coefficient 1 are just plus or minus 1. So I'm going to put in my new equation, x to the 4th plus 4x squared minus 32. And this time, because it's an x to the 4th, I need to find at least two x-intercepts. So if you look at your graph, it looks like negative 2 and positive 2. Okay, so I need to use, I'll go negative 2 first. So we have 1, 0, 4, 0, negative 32. So why the zeros? Well, there was an x to the 4th, but no x cubed, 4x squared, no x's, and negative 32. All right, so do your synthetic division. And if you get 0 as a remainder, that's good. Then use your other 0, which was 2. All right, do your synthetic division again. 0 as a remainder is good. And then this time I get x squared plus 8 equals 0. All right, so instead of using the square root method, I'm just going to use a quad. And I have, go to Program, find a quad, hit Enter a bunch of times. And 1 is my A, 0 is my B, and 8 is C. And it says it's unreal, so hit Enter one more time, and you get 0 plus or minus 2 root 2I over 1. So remember, you don't really have to say over 1, and you don't have to say 0 plus something. So my answers are positive. Now we usually write 2I root 2, but if you say 2 root 2I, that's fine. So these are two answers, 3 and 4. Right? You should have the same amount of answers as the degree of your function, which in this case was 4. All right, so your secret word of the day is skip number 5. So we're going to skip that problem. And we're going to head to number 6. So we've got another x to the 4th. So again, I'm going to graph it. You can exit out of your A quad. Just quit out of there. I'm going to type my equation in. All right, but I should make my p's over q's list because sometimes the x-intercepts are a little hard to see. So if I make my p's over q's, I've got factors of 4, which are 1, 2, and 4 over 1. All right, so hit graph, and hopefully I can find two solutions. So it looks like 1 and something is not working out right here. Because it should be 1 and negative 1, but I don't see a solution at negative 1. All right, so we'll skip number 6 also. We'll just skip that one. All right, we'll go to number 7. So let's see, we need factors of 81. So we got 1, 81, 3, and 27. We have 9 and 9, right? And factors of q are just plus or minus 1. So I'm going to type my equation in, and we've got x to the 4th minus 81. And we look at our graph. We need to find two solutions, so we can do synthetic division 2 times. So there's 3 and negative 3. All right, so be careful when you set up your coefficients. There's an x to the 4th, but there's no x cubed, no x squared, no x's, and then there's your negative 81. All right, so I got 0 as a remainder. That's perfect. And then I do my synthetic division one more time. And I got 0 as a remainder again. So I have x squared plus 9 equals 0. All right, so I just want to show you, if you do a quad with this one, it's fine to do it. It just looks a little funny with your answer. So 1, 0, and 9 are A, B, and C. And you get 0 plus or minus 3 root 1I over 1. So remember, you don't need to say divide by 1. 0 plus anything is just that thing. So plus or minus 3 root 1, what's the square root of 1? That's 1. So all this is really just saying plus or minus 3I. And I know it's kind of crazy. I'm not sure why whoever programmed this couldn't get rid of the square root of 1, but that's how it works. So we should have 4 solutions. So my roots are 3, negative 3, right, from earlier, and we looked at our graph, positive 3I, and negative 3I. So there's your 4 solutions. All right, so let's look at the last problem. And what's wrong with this? We have a plus 12 that we have to do. Now, it's only x cubed, so that means that we only have to find one solution in our on our graph to do our synthetic division. Sorry, I'm going to erase that. I'm going to do my factors of 12. So factors of 12 are 1, 12, 2 and 6, and 3 and 4. And all my factors of q are just 1. All right, so on my graph, I've got x to the third minus 4x squared minus 3x plus 12. All right, so I need to find just one solution, and it looks like, well, it looks like negative 2, but it's not. It's going to be close to that. It looks like positive 2, but it's not, and I think it's positive 4. All right, so positive 4, and then I have 1, negative 4, negative 3, and 12. And I'm just going to do my synthetic division. All right, so I get x squared minus 3. And if you want to do a quad, you can, but I'm just going to add 3 and take the square root. So I get plus or minus square root of 3. So that's what these numbers were. If you type in square root of 3, that's what that solution is, and negative square root of 3, that's what that solution is. So my answers, my roots, are 4, positive root 3, and negative root 3. And again, remember that you should have just 3 solutions on this one because it was x to the third power. If it was 4 solutions, that would be only on the ones that have x to the fourth power. All right, so let's go back to problem 6. I think I figured out, I think I typed it in incorrectly. So here's the graph. I must have typed in x cubed instead of x to the fourth. So I need to find 2 solutions, which are 1 and negative 1. Okay, and it doesn't matter which one you do first in your synthetic division. So we have 1, 0, 3, 0, and negative 4. And if you do your synthetic division, okay, I get 0 as a remainder, and I do it one more time. 0 as a remainder, so I have x squared plus 4 equals 0. And if I subtract 4, I get negative 4, and if I take the square root of negative 4, I get plus or minus 2i. So my solutions are 1, negative 1, 2i, and negative 2i. Okay? And so you should have written down the secret word already.